We call Kubernetes in shortcut as K8s as well, and this is container orchestration tool. I'll say. Okay, what does this orchestration meaning? Orchestration, it means in another term or another terminology, management. Okay, so we can consider Kubernetes as container management tool as well. Now, till last 6-7 days, we have learned about the Docker, and within the Docker, we have learned about the containers a lot, like how to create container, delete it, start, stop, attach volume, environment variables, port mapping, network, Docker compose. A lot of things we have seen in last 6 to 7 days about the containers. Okay, so who is going to manage means what does management means, or what are the roles and responsibility of the Kubernetes as part of the management. Okay, so let me tell you some drawbacks about the Docker. Okay, so let's say this is my Docker host, okay, in which Docker is installed, and let's say I have created two containers over here. So I'll just name it as a Docker host, and this is the container C1, let's say, and C2. Okay, and let's consider this C1 and C2 are belongs to a Flipkart application. C1 belongs to the front end and C2 belongs to the back end. Let's consider in that way. Okay, and what if this C1 container goes down automatically, because let's say there are thousands of requests coming into this container, and if this container gets hang, and there is shortage of memory and CPU, or shortage of resource you can consider on this container, then this container will stop responding and this container may get deleted as well automatically. In that case, who is going to create a new front-end container? Okay, who is going to create a new C1 container? Because in case of Docker, this container gets deleted, then a person should be there to monitor the status of the container, and that person needs to check whether each and everything is there within the Docker host or not, all the containers are created or not, and if there is any issue with some container, then that person manually needs to fix that issue and create a new container. Okay, so this is one of the drawback of the because let's say there are only two containers, it's easy for me to manage manually. But let's consider there are thousands of containers, 2000 containers, in which it's very difficult to manage manually, or with a human eye it is very difficult to find it out which container have some problem, and we have to recreate that container. So those things needs to be fixed automatically, not manually. Okay, because as we are into the automation world, so each and everything should be automated. So in case of the Docker, this container goes down, then there is no way that automatically this container will be up and running. So that's where Kubernetes comes into the picture. And the funda of recreating that container automatically, we call it as a self healing. Okay, self healing is nothing but one of the great functionality provided by the Kubernetes, in which if any of the container gets deleted automatically, in that case that container will get recreated by the Kubernetes. So Kubernetes will take care of creating a container if the container gets deleted. That's why we call this as a management tool. This is the one of the functionality of management tool. There are many others. We will talk one by one. Okay, but this is the first and foremost important functionality provided by the Kubernetes about the self-healing. In case of the self-healing, there should not be any manual or this process of creating a container is automated now. Like it's taken care by the Kubernetes. That is the one thing. Then Second thing, let's consider, let me redraw this diagram. Second thing, let's consider there are two containers over here, and with the same like front end and back end containers. Okay, C1 act as a front end, C2 act as a back end. And what if there is a lot of load on this Docker host, or there is some hardware issue on this Docker host, and this entire Docker host is inaccessible, or it is now into the shutdown mode. In that case, all the containers which were there on this Docker host will also get deleted, because this server is no longer exist, and this server is no more accessible. So that's where the containers were hosted previously on this Docker host will get deleted, and your application will not be accessible because the containers are not there. So this is also one of the drawback of Docker. In case means we haven't seen the drawbacks till now, because we were learning Docker at initial days. So that's where I don't wanted to start with drawbacks, but right now you can understand those drawbacks properly, because now you have idea about the Docker. Okay, so if this entire server goes down, in that case, definitely all the applications and all the containers in which our application is hosted will get deleted, and everything will stop working. Okay, but in case of Kubernetes, we have one of the functionality that is nothing but auto scaling, in which if any of the Docker host or any of the server gets down, an identical server will get created automatically. Okay, and these two containers will get shifted or created again on this new server. Okay, so this new server will get created automatically with the help of Kubernetes, and these two containers will get created over here, so that our applications will be up and running always. And this creation of the new server is like automatic. We don't have to worry about it. It's like a seamless process. Okay, so in case of the Docker, we were working only on single server, but in case of Kubernetes, we can work with one server, two server, three server, four server, as many as we want for our workload to handle. How this is happening and all those things, definitely we will talk into the practical. I will show you each and everything practically as well, but as of now, just understand the theoretical concept and the functionality, and which all things provided by the Kubernetes. Okay, now next is like, let's say, let me redraw it one more time. Let's say in Kubernetes we are working on two servers. Okay, so where we can host all our containers. Okay, let's say this is the small server of capacity, let's say uh, RAM equal RAM is let's say 4 GB, and to this server I'll allocate RAM as 8 GB to this server, and within the Kubernetes I can host my workload in multiple nodes. Nodes are nothing but the host. Okay, but in terms of the Kubernetes, we call that as a node. So I'll also consider host as a node when when we are learning the Kubernetes. So let's say now you want to create a container. Okay, and that container is having means that container requires RAM equal to almost 5 GB. Okay, that is the requirement, means that if the application within the container requires some extra GB of the RAM, so that that will be smoothly running. In this case, I know that the first server is not capable enough to take this container, because the size of the RAM allocated to this server is 4 GB, and RAM allocated to the second is 8 GB. So definitely this container will go on this server. So who is going to decide that? Because I will not consider whatever might be the size of the servers in background. I want this container to be up and running anywhere. That is my requirement. So who is going to check on which server this container is suitable? So that is checked by the Kubernetes. Okay, so that one part eh, of the scheduling is also taken care by the Kubernetes. Means this container should go on which server is decided by the scheduling thing. Okay, it should go on to the first one or it should go on to the second one. It all decided and taken care by the Kubernetes. We don't have to worry about it. We just have to create a container, and automatically that container will get created either on the first node or on the second node based on the scheduling fundamentals of the Kubernetes. Let's say we have one more container now over here. I'll say, let's say we have this container with RAM size as, let's say, 2, and now this container can go on to the first as well and can go on to the second as well. In last case, this container was going to the second one by default because there was enough RAM on the second one. But now this 2 GB RAM is available on both the servers, so it's in my hand as well. Like if I will uh, take advantage of the scheduling part within the Kubernetes, then automatically this can go to the any server. But if I specifically want that this container should go only on the first one, it should not go on the second one, that also I can define within the container information that this container should go only on the first one, not on the second one. So it's in my hand as well, like where I have to put my container, in the first node or on the second node. Okay, so both the facilities like automated scheduling is also possible via Kubernetes, and Kubernetes allow us to schedule that container on any of the node depending upon our requirement. So that is also possible in the Kubernetes. We call that as a scheduling. And this auto scaling, we were talking about the in case of node. Okay, then we have one auto scaler as well for container. Okay, what does that mean? Okay, so let's say we have a front end application over here, and there are two containers running for the front end, and one container for the front end is over here, one container for the front end is over here. Why we are doing so? Because okay, let me talk about the rest of the things first. This is the backend containers. Okay, let me talk it let me write it down. This two belongs to the front end, this two belongs to the backend. Why uh, the thing is, let's say if you are trying to create two containers for the front end, then automatically those two containers will get distributed amongst the servers. If this is, let's say, a node 1 and this is the node 2, okay, now you may be thinking like why we are working on the two servers, why not only a single one? Okay, because there is an advantage of having the two servers in the Kubernetes, because minimum two servers, not only two, minimum two servers. Because let's say if I have deployed two containers for the front end, so automatically Kubernetes will schedule one container on the first node, second container on the second node. So there will be some equal distribution of the containers as well amongst this node. If you have deployed, let's say 10 containers, then 5 container will get uh, 5 container will be scheduled on the node 1 and next 5 will be scheduled on the node 2. This is the automatic scheduling part which is taken care by the Kubernetes. Why we are doing this 50-50%? Because at any point in time, if this node 1 gets crash, our application should be still up and running because there are front end and back end containers up and running on another node. So there should not be any impact on the end user case where they should not be face an issue of inaccessibility of any application. So that's where we will always play with minimum 2 nodes so that there will be an high availability of our application. That's where we will always work with 2 nodes to host our container. Okay. And another benefit is like, let's say if we have this 2 front-end containers and 2 back-end, and if there is any big billion day like Flipkart as we have discussed earlier, and there are a lot of requests coming to this containers and same for this as well, and these 2 containers are capable of handling only, let's say, 10 requests per second. In that case, and on a daily basis we definitely get 10 requests per second, but let's say on the big billion day there is a lot of traffic on that website and hundreds or thousands of the requests start getting hit on that containers. In that case, definitely those containers will be heavily loaded, and we have we want extra containers to handle those extra requests. So automatically, with the help of autoscaler, if there is a load, much load on this container, so Kubernetes will automatically create a new containers over here. So Kubernetes is smart enough to create new containers whenever required. Okay, and once the big billion day gets completed, then Kubernetes is also smart enough to delete those extra containers. Okay, so each and everything is happening automatically over here. We just have to write our code according to that, and things will get takes place automatically. We don't have to worry about it. So even there is big billion day, we don't have to worry because Kubernetes will take care of increasing the container at right time. Okay, so this autoscaler of the container is also one of the great benefit. uh, Over here manually we don't have to increase the number of containers for the big billion day like we did in the Docker Compose. You know, Docker Compose, we have scaled the containers for those services front end 5, 10, 20, but that scaling was manual scaling. Okay, over here this scaling is nothing but automated scaling without any human intervention. The scaling will happen, and the number of containers will get created automatically, and once that gets finished, then those extra containers will get even deleted as well. So auto scaling is nothing but increasing the number of containers and decreasing as well according to the situation. And there are other benefits as well to this Kubernetes, but we will just stick to this benefit as of now, because once we will go through within this practical or hands-on with the Kubernetes, then definitely you will understand the other benefits as well. Okay, so any doubt till now or any issue in understanding of the benefits? Okay, so in case of the Kubernetes, the way we don't have to create a cluster manually. Okay, means Kubernetes is all about working with the cluster. Okay, cluster is nothing but combination of the nodes. So as over here there are 2 nodes. Okay, let's understand the terminology now. Like Okay, when we will learn the Kubernetes, that time we will always work into within the cluster. Okay, this is the Kubernetes cluster. What which all things are present within the Kubernetes cluster? One, there should be minimum one master node, and there should be one or more than one worker node. Okay, so I'll just take it as a two worker nodes over here. This is the master node. This is, let's say, worker 1, worker 2. Okay, worker 1 node, worker 2 node. Okay, then as you know that each and every container will get deployed over the worker node. Worker node is mainly for handling the workload. Means each and every container will get created only on the worker node. These are all nothing but a servers. Okay, the way we have Docker host, the way it's all about the Unix servers or Unix box you can consider. So worker 1 and worker 2 are mainly for handling the workload. In layman language, the containers will always get created on the worker node. Then why do we need master node? Master node is mainly for the management. Whatever benefits that we have discussed so far within this Kubernetes section, all those benefits or all those functionality is taken care by the master node. So master is only responsible for managing the containers over the worker node. Okay, so if the container over the worker node gets deleted, then master is responsible to recreate that container. If the workload on those worker 1 and worker 2 server gets increased, then we need to create one more worker node, worker 3. So who is going to create that? Master node. So each and everything, so master node is nothing but a monitoring server you can consider. Along with that, it is acting as a management server as well, because from this master node only each and everything will get managed about the containers. Okay, so let's try to go ahead and create a cluster. Okay, so meanwhile I'll just go to DigitalOcean, go to digitalocean.com, and on the very first day we have created our account over here, and we got 200 credit back as well, which will valid for the 2 months. So it's been already 15 days, so that's why there are 45 days remaining. Okay, now go ahead and create the Kubernetes cluster. You can see over here we have Kubernetes, create Kubernetes cluster. Click on that, and let's go ahead and create in the Bangalore region, which is near to us, so that's why we are selecting Bangalore. And let's take the recommended latest version of the Kubernetes, because there can be 1.26 is the latest version of the Kubernetes, but these are the previous version of Kubernetes. So let's go ahead and learn the things on the latest version. And right now, let's say I'll just say a node pool. Node pool is nothing but a cluster of the worker nodes. Okay, entire thing is Kubernetes cluster. Okay, master node, worker node, combination of each and everything is Kubernetes cluster, and combination of only worker node, or it comes under the node pool. Okay, then machine type droplets, then how many worker nodes you need. You need one worker node, two worker node, three worker nodes. So let's say I'll play with two worker nodes. Okay, and what will be the size of those worker nodes? Like 2.5 GB RAM usable, so 4 GB total. So let's see if I uh, create a cluster now, then my host or my servers will have this 4 GB of the RAM and 2 CPU. Okay, but I don't know, want that much extra, so what I will do, I'll just keep it minimum, because we will be running very short workload over here, or very small workload on our Kubernetes cluster. So that's where I'll choose $18 per month per node, and you don't have to pay anything. It will all get deducted from this 200 credit that we got while doing the sign up. Okay, so we are creating a two worker nodes over here, and we can schedule our workload on these two worker nodes. Keep rest of the thing as it is, and you can give your cluster name as well, whatever the name you feel. Let's say DevOps cluster, and that's all. So total cost will be $36 per month, as $18 per month for the one server, and we are creating two servers, so that's why $36 per month. So don't worry about, you don't have to pay anything over here, so let it be. So with this we can go ahead and create a cluster. So this cluster creation will take almost 10 minutes, because internally it will create a virtual machine. It will install all the Kubernetes related things, then it will connect to each other. So there are a lot of things happening in the background, that we will discuss later on, because right now I don't want to bombard you with a lot of technical knowledge about the internal working of the Kubernetes. So let's keep these things on the high level. So our cluster name, we have given as this Kubernetes DevOps cluster, and within that two virtual machines will get created, and that virtual machines will be required to schedule the workload. Okay, so let it take some extra time, almost 7 minutes to 10 minutes time. Meanwhile, we will just discuss about more of the Kubernetes. Okay, so in the same way, you also have to go ahead and create the Kubernetes cluster, because if you want to practice along with me, you have to create a cluster, otherwise you won't be able to practice along with me. Okay, so go ahead and make use of this 200 credit which you are having, and play with it as much as you want in next 45 days. Okay, so this cluster is getting ready, a master is getting created, and worker nodes are getting created. One thing I just wanted to emphasize over here, that the I mean to say, as this is the cloud provided Kubernetes cluster, okay, we are not doing anything to, like, we are not manually creating virtual machines, we are not manually installing Kubernetes components within that. So each and everything is like cloud provided, cloud agnostic. Okay, so that's where cloud don't provide access to the master node. Okay, so this management will taken care by the master node, and that management, we don't have to worry about the master node, because the task of this master node is to manage the containers on the worker nodes, and that will happen in the background. Okay, as a DevOps person, we just have to create the containers, and that containers will get shifted to worker 1 or worker 2, depending upon the scheduling fundamentals. We don't have to worry about that, and so that's where there is even no need to get access to the master node. So we will never see master node in our cluster, means even though it will be there within the cluster, but we won't be able to access to this master node. Okay, because that's maintained and managed by the cloud provider. So DigitalOcean is one of the cloud provider that we are currently working on. So DigitalOcean will take care of the master node, and we will take care about the worker node, means, so that's where we won't be able to do SSH or log into the master node just to see the components. We can look for each and everything from outside as well. There is even a 0% requirement of login to the master node. Okay, we can work without, means without having access to the master node. Okay, that's what I'm trying to say. So let's wait till this gets completed. Meanwhile, this cluster we will have the master node, and there will be the worker nodes. What is the difference between master node and worker node? Master is mainly for managing the containers. Worker node is mainly for like handling the workload. And who defines what, like which one is the worker, which one is the master, like what are the differentiation internally? When it comes to the differentiation at technical level, it all comes, I mean to say, it's all about the components, which all components are installed on that node. Okay, so master related components are installed over this master node. Worker related components are installed on this worker node. Okay, so which all components, because it's not just a normal virtual machine, there are some extra things installed on that server. Okay, you can see over here, this is the master node, this is the worker node, and in the master node we have Kube API server. Okay, just these are the components. One is a Kube API server, another is HCD, then this controller and scheduler. So there are four components installed on this master node. And who is going to install all this? It's a digital ocean for us. Okay, because we are making use of the cloud provided Kubernetes cluster. So nothing we have to install. All these components will get installed automatically on our master node. Similarly, for the worker node, we have this kubelet and container runtime, which is which will be there on the worker node. So you can consider these are nothing but a software, or you can consider these are nothing but a processes which are up and running on the particular server. So masters, mainly in the interview, they will definitely ask the components of the master node and components of the worker node, and how architecture look like about the Kubernetes. So you just keep in mind, uh, there is a Kube API server, then there is HCD controller scheduler in the master node, and two components in the worker node. Now we will talk about the internals, like what is the functionality of each and every component, like why there is controller, why there is scheduler, what is the benefit of having the scheduler. Okay, let's talk about that a little bit. Okay, let's say this is the master node and this is the worker node. Okay, and first one let's consider as a scheduler. Scheduling is one of the component which is available on the master node, and these are the worker nodes. So let's say, as a DevOps engineer, I want to create a pod. Sorry, I want to create a container. Okay, then that container will get created on the first one or second one. Okay, first worker node or second worker node. It's decided by the scheduler. Okay, so scheduler is the one who is going to decide on which worker node our container will get shifted. Then we have controller. Okay, in case of the controller, what is happening over here, that let's say if there is already certain containers are up and running, one, two over here and two over here. Let's say two containers are running on the first and another two on the second, and suddenly this container gets deleted because of some high load on that server. Okay, In that case, who is going to recreate that container? Means ideally it there should be, one more container should get created automatically at this location if the previous container gets deleted. Then who will take care of creating this extra container if there is any damage to the running container? Okay, so that is nothing but the controller will take care of creating the container if there is any issue. Similarly, controller will take care of creating the extra worker node if it require over here. So controller is all about creating the containers if there is any problem. Then there is an kube API server. This is also one of the component. This kube API server is an entry point to the cluster. What does the entry point means? Let's say I have requested to this cluster to create a container for me. Okay, in that case, who is going to receive that request initially? Means who is going to take care of that request, who is going to uh, fulfill that request? That is nothing but kube API server. Kube API server you can consider an entry point to the Kubernetes cluster. So whenever you request anything to the Kubernetes cluster, that request will get accepted by the kube API server, and then kube API server internally talk with some other components, and then things will happen. Okay, so as of now just keep the basic idea about it. Tomorrow also we will just discuss the same thing about this cluster architecture in great detail, but just for timing just understand what exactly is done by this each and every component. And last is nothing but HCD over here. This is nothing but a key value pair. uh, let's say if I show you some, or if I just tell you something some information about this. Let's say our cluster is running with this architect, with this, okay, one node, sorry, one pod, one container over here, two container over here. Okay, so HCD is a component who will have all the knowledge about our cluster, like how many worker node we have within the cluster, how many uh, containers are running within the cluster, what are the resources allocated to that worker node. So in short, HCD is nothing but a brain behind the Kubernetes, because each and every information about the Kubernetes cluster is available to the HCD. Okay, and that information will get keep on updating. Let's say if I request to the Kubernetes cluster to create one more container, and let's say that container gets created over here, so that information will get added to the HCD that a new container got created on the worker node. And if that container gets deleted over here, then information will again come back to the HCD that the container gets deleted. So each and every information about the cluster is held by the HCD. So you can consider this HCD as a brain behind this management, because क्लस्टर के बारे में आइडिया होगा तभी तो क्लस्टर को मैनेज कर पाएंगे. If you don't have any monitoring, or if you don't have any idea about the cluster, like how many containers are there, how many worker nodes are there, what are their sizes, and each all things, so then only like you will be able to manage it. Otherwise definitely you won't. And there are two components on this worker node. One is like kubelet, and second is like container runtime. I'll say container runtime is nothing but which kind of container we are going to create. Like we want a Docker container or a Rocket. As I told you in the Docker section, that Docker is not a single company who is going to create container. Okay, there are many other uh, companies who, or many other tools who allow us to create container, like Rocket is also one of the RKT we call it as a, that is also one of the tool who allow us to create container. And there are two three extra as well, I am not able to recall right now, but Docker is one of the um, you can consider one of the important and one of the maximum used, okay, or widely used in the companies. Okay, so that's where we will consider this container runtime as a Docker. It means the containers that will get created, that will belong to the Docker container. That is the fundamental I'm trying to explain. So container runtime is nothing but a tool that will create a container for us. And the last one is like kubelet. What is the fundamental of the kubelet? Okay, the thing is, whenever I will request to this cluster to create a container, in that case request will go to the kube API server, then container will get created in the one worker node or two worker node. So who is going to receive that request from the master? So that is nothing but kubelet. So kubelet is act as a captain on this worker node who is going to receive the request from the kube API server. Because initially the request is taken care by the kube API server, then this request will get transferred to the kubelet. So kubelet is a captain on this worker node, and each and every worker node will have kubelet and container runtime. Okay, so the components over this worker node will remain same on each and every worker node. And internally this kubelet will ask this container runtime to create a container, and once the container got created, this information will be sent back to the kubelet that container got created. Response will come back to the kube API server that the container is created, and that information will get saved to the HCD that container is created. So internally this flow will happen, uh, but you will not be able to see this uh, with your naked eyes. Okay, that something is, but in internally this is going to happen, you won't be able to see it directly. Okay, so this is an overall idea about the Kubernetes and its components and its, I mean to say, architecture, advantages, and all those things. And at the same time, I hope our cluster is also ready. So yeah, this create cluster, Kubernetes cluster got ready. So we have created a Kubernetes cluster over here, and you can see 2 out of 2. That means there were 2 worker nodes, and all the worker nodes are up and running over here. So we will see how this, how to connect to this cluster tomorrow, uh, as that is also one of the good concept to understand. But till now whatever we have discussed, like the cluster, what is the cluster, what is the master node, worker node, benefits, components. Maybe components का आपको इतना जल्दी पूरा नहीं समझेगा. Once we go into the practical, that time you will understand like where these components are getting used and all those things. Definitely things will be much and more clear with the practical, but as we should know some theoretical or some overall background about this, that's where we have covered. Any doubts so far within this?